Hello everyone. In this video, I wanted to do a quick overview of the Python ecosystem on dashboards. So this is something that may be useful for professional work, also local work if you're a developer, or just looking to get familiar with everything and all the tools libraries that are available currently in Python in 2025. Um, we'll go very quickly over most of them and the most relevant ones. For certain, I have used them all in professional settings, at work, for hobbies, and any implementation that you may need to do. As usual, I will leave all the links in the description of the video, all the relevant references, so you can take a look if you want to do that straight away. Starting with the content, we can first of all mention pandas, obviously, data science, but really it's just a data library from Python that allows you to have tabular data and data sets for organizing the data, loading from Excel spreadsheets, Excel files, CSVs, text files, and just load and control the data that you can use for any of the dashboards. You can retrieve the data and have them in pandas data frames from different databases, converted from JSON to CSV, vice versa. Obviously, very well integrated into Python. It's been around for many years by now. It's very performant, although it does has um, a few downsides, which is why also Polars with the new whole Rust programming language movement, let's say, of such a high performant language as such as Rust in comparison to, of course, Python, which is an interpreted language, it allowed to create and write from scratch a new pandas sort of library compared that has a few benefits in performance in using multiple cores in your system and also using um, lazy computation when you need to process different things. So in the case of polars, if we quickly go, the the examples are quite straightforward. What the operations group by, aggregate computations, filtering on the data, loading a CSV. So of course, both polars, pandas are used to loading data from multiple data sources, from the web, from CSV files, from text files, from any kind of format really, including JSON files. And you can use either pandas or polars independently. Is really not a problem. They have the Python interfaces. And going straight to the libraries that allows us to build dashboards, we have to start with Dash. Dash is a library that has been created a few years ago. It's built on top of Flask. It does long polling for some of the features and functionality that it provides. And if you think about Dash as an abstraction just to simplify, by writing only Python, you can have a front end which allows you to have callables and reactive elements on the UI on the HTML page to have events um, getting triggered from different events that occur when you interact with the front end. So quite simple, this minimal Dash application. This entire documentation actually from Dash is built on Dash itself. Um, and you can see how it's using pandas to load the CSV file. It instantiates an app the same way that Flask or FastAPI instantiates a service, if you're familiar with FastAPI or Flask. And then, of course, you define a layout, which is all from Python, but you can see how HTML.h1, a header 1 in HTML, a drop-down element. It identifies from the dataset that we loaded before, the country column. It gets all the unique, so this gives a sequence or a list, if you will, of the different countries. And then, of course, you set an ID. This ID is relevant because it will identify the element that is triggering the event caller. So you can see we handle callbacks based on things that happen, and then we update the graph. Now is a good time. Of course, this is all real time. You can see that if I pick different countries, the graph automatically changes. This is how easy it is. I have to jump straight into Plotly. Plotly is the graphing or visualization library from Dash, from the same creators. And Plotly it has a JavaScript library and the Python interface. A JavaScript library, of course, is the one that allows us to see all the plots and charts on Dash, but you don't have to use Dash necessarily when you build your Plotly charts. You can absolutely use them and it runs on Jupyter notebooks, and you can absolutely use just raw JSON and then use the JavaScript library to interpret and create and render all the charts that you can see here. A lot of examples, I'll leave the link in the description so you can see a lot of all these very, very cool graphs that can be created. As you can see, completely three-dimensional. You can look at navigating, downloading into multiple formats, tons of examples really. So we've covered Dash and Plotly. With Dash, you can do very, very complex dashboards. We're not going to go into each of the details for each of the possibilities, but know that Dash is definitely the top used dashboard library when you want to create um, something more complex. Then Plotly, the plotting library, does not really need Dash. You can use JavaScript directly or your own. Another Python library for building dashboards would be Gradio. As you can see here, of course, it's focusing on machine learning apps. That means because machine learning normally requires quite a few elements that allow you to, move around different sliders and different elements and see and visualize very quickly from an event that something that you touch or you change a parameter and you want to see the output is absolutely very relevant. But uh, as you can see very quickly, you have a few lines of Python and you can just run locally a service that allows you to visualize a simple web interface, which is the purpose of a dashboard. Absolutely, you can always export once you have a web application into PDF. You can customize it to save it to HTML. You can output or export using multiple other libraries, taking screenshots and other things if you need a report that is absolutely separately uh, standalone without really needing a service in the case of something else that you may need. Streamlit is another great comparison from Gradio. Now we go to Streamlit. It allows you to do pretty much the same as you can do with Gradio, right? So you have a lot of, if we go to gallery under examples, you'll see absolutely a lot of examples that show us the capabilities that Streamlit has. Whether to use Streamlit, Gradio goes a lot on preference. We can see how little by little it gets created the HTML from the code. All of these libraries so far will operate in a similar manner. You will always have initially a to you will always have a few lines of Python, fully on Python, and they will generate and render an HTML, a front-end page, that will contain elements, that will contain events, that will contain callbacks, and they will execute different code paths depending on what you want to do, right? So ultimately, that's a dashboard. The dashboard is meant to provide you with a snapshot of data, a visualization of data, or some metrics, some numbers, something to take insights from data. So whether you use Pandas Polars is really not dependent, on the functionality, but what you are most familiar with, the performance that you need, and preferences that may be from project or the team or what you really want to do. Then we went, of course, Dash Plotly, and then, of course, we look at Gradio and Streamlit. Now, for additional things on plotting and as we mentioned, Plotly, for plotting, the standard and de facto in Python, of course, is matplotlib, so we couldn't stop or make this video without mentioning Matplotlib. It has probably decades by now of maturity, and it's very, very advanced, flexible, and completely full of features. You can even create animations and videos from it. Of course, internally it uses other libraries to accomplish all of that, but it absolutely has the most powerful ecosystem to create and customize your charts and plots as you want. Of course, huge tutorials, user guide, definitely the documentation will be there if you use GPT or any LLM for asking it questions about what and how to do something on Matplotlib, you'll find a lot. Another most recent plotting library, recent, well, it's a relative term, but Bokeh. Bokeh is a great one that is very similar in terms of perhaps the styling or approach to Plotly, where there is a JavaScript rendering engine or library. Because it is interactive, it runs on the browser, and it makes it very easy to make very cool plots quite easily. Now, of course, you can always download and upload and output all the plots into different formats. So that's something that you should keep in mind always. Of course, it integrates with Jupyter notebooks, web pages, PNG, SVG. We see all the standard things. The most recent one, it's Altair. Altair has tried to take a step further into the generalization, perhaps, and trying to bridge together the gap of all these plotting libraries we just mentioned. You can accomplish everything with all of them, but the lack of a standard way for generating plots is something that I believe the Altair designers thought a lot about. The idea that in the end, plots or charts are nothing more than just data points, right? That you want represented in some way. So if you want to put the data points in a manner, uh, you should be able to, regardless of everything that you're using. So if we go to an example here very quickly, we can see how straightforward it is. In this case, this line is just loading the data set, and here is just showing how to generate this chart. And you can see, as usual, in all the libraries, you can export it and save it in multiple formats and view the source code. And they even have a friendly editor that allows you to, play around and see how the data set and each data point is actually seen by the library and how it's rendered. So with this, pretty much we covered all the libraries that I wanted to talk about on dashboards. This is the state of the art, absolutely, that I've seen across the world on dashboards in Python. Worth mentioning, of course, will be first of all Fast API, because as we mentioned, most of these are JavaScript libraries. So if you have JSON and you have an endpoint that can return a JSON and the data points that you need, you can create your own API with your own dashboard, whether that is some endpoints generating a real-time PDF using Bytes.io, or encoding something dynamically, fetching data from another resource, and then generating your own chart on JavaScript. You could do all of that using Fast API. And absolutely, for someone that works in dashboards, or if you require much more flexibility in the dashboard itself, more control, more flexibility than what Dash would provide, definitely you should consider Fast API. And it's good to mention Flask, right? Flask was the de facto micro framework for web applications or APIs, REST APIs within Python, until Fast API came along. And Flask has pretty much exactly the same um, interface, the same approach to building a web API. The difference, of course, is that it is not natively asynchronous, and that has pros and cons on different things, but it's been around for ages. So absolutely, it would be a preference with a few caveats on constraints and restrictions technically that you may have for choosing Fast API. and Flask, and if you have familiarity with one or the other, it wouldn't change a lot unless you really needed one or the other for some reason. And the final uh, mention will be for Chainlit, which is another library in Python that is very, very recent. But its purpose, its objective has always been to be more for a chatbot or chat interfaces. So the idea of interacting with an application. And if you think about this, you may have seen it a lot used with LLMs or large language models recently, but the idea was always that this could be an interface to anything. You can have, just a user chatting with an application doing general string matching or regular expression matching, intent identification. So if you're chatting with something and you need just to do a search or some content or basic user interactions that before the LLM world, it could have been just simple um, asks FAQ or searches on a database or some interaction users or developers could have had. Very easy to make all of this in just very few lines of Python. So as usual, I'll leave all the links in the description. You can see how easy pip install as usual, and then you just run it. You can have a simple function that will implement everything that you can see. You will have decorators, as with most of the libraries that we've seen, especially the ones covering endpoints and API implementations. They absolutely have this. Uh, Decorators allows to very simply just define different things and behavior that you need in your application. So with that, I'll leave all the links in the description. Hopefully this was useful. The idea was just to make a quick review of the tools and libraries in the Python ecosystem that have been being used for quite a while to build any sort of dashboard in particular. This, of course, applies to data analytics, data science workflows, data engineering workflows. All of these tools at one point or another, if you're using Python, you will come across. And dashboards can apply for anything from infrastructure monitoring to day trading real-time applications, right? So these are just the tools at your disposal. You will probably use and pick just a few of these because obviously the use cases are represented or solved. Many of the use cases can be fulfilled by three of all of these libraries that we just saw, right? You just need a visualization layer and the backend layer and the library to deal with the data formatting, filtering, etc. Right? And we are not talking about the infrastructure. Hopefully this was helpful. Let me know if you would like any specific content and see you on the next one.